In this mini lecture, we are going to discuss the basic protocol for preparing solutions. So preparing a solution with a specified concentration really boils down to a 5-step process. So the first thing you're going to do is determine the number of moles required from the volume and concentration of the solution. So for example, if you know that you need, say, 500 milliliters of a 0.01 molar solution, you're going to use that concentration and that volume in order to determine that number of moles. Once you have the number of moles, in the second step, you'll use the molar mass to determine the mass of solute required. Remember, in the laboratory, we don't count out moles, we measure the mass. So we'll convert that moles to mass, and then, of course, you'll weigh out that required mass, and you'll then add that solid to the volumetric flask first. Okay, so the solid must be added first. Then you'll fill up that volumetric flask to the desired volume using DI water, and you'll basically put a little bit in there, swish it around, wait for that solid to dissolve. Once that solid is fully dissolved, then you will add the rest of the DI water up until that desired volume is reached. Okay, so to illustrate this, let's say for example, we wanted to come up with a 1 liter volume of a 1 molar sodium hydroxide solution. So we want 1 liter of a 1 molar NaCl solution. So in order to get 1 liter of a 1 molar solution, you're going to have to weigh out 58.54 or 58.44 grams of sodium chloride. You're going to put that sodium chloride into your volumetric flask in the first step, add some water, add that DI water until it's dissolved, mix it up thoroughly, and then add the final amount to bring that volume up to the 1 liter mark. Okay. So relatively straightforward process, but it's very common that I see students make some errors here, and that most common error is to basically start off by filling up the volumetric flask to that 1 liter mark and then adding your solid. All right, so you have to recognize that if you do that, if you fill up that 1 liter volume first and then add the solid, well, you're effectively adding mass, and which takes up volume, and as a result your final volume is going to be greater than 1 liter, and as a result you're going to end up with a solution that is something less than 1 molar. Okay, so the key take-home message here is add that solid first, make sure it fully dissolves, and then fill it up with water. Okay, so let's look at some of the calculations and a little example that are involved with this process. Let's assume that we want to come up with a 1.75 liter volume of a 0.122 molar solution of potassium bromide. All right. So in this first question is asking us how many grams of potassium bromide are going to be required. So to determine the number of grams of potassium bromide, we basically have a 2-step process. First, we need to determine the number of moles. We're going to determine the number of moles by using the desired volume and the desired concentration and basically multiplying straight across. We know that we want a 0.122 mole per liter solution. We're going to multiply that by the volume. Liter units cancel out, and we will be left with 0.2135 moles of potassium bromide. Once we have the number of moles potassium bromide, in our second step we can use that molar mass of potassium bromide, which is 119.00 grams of potassium bromide per mole, multiply through, and we will arrive at our final answer. And notice that I've kept the significant digits here marked in black, and I haven't rounded until the very end. So I carried this 5 from the first calculation down to the second calculation here, but kept in mind that only 3 significant figures were present, and then performed the final rounding at the end of the day. So if we're going to make this solution, then we would weigh out 25 0.4 grams of potassium bromide and add that to our volumetric flask before adding that solution, DI water. Okay, so let's look at one final example here. In this example, it's a slightly different problem, but the same principle. Suppose you have a 10.199 grams of solid sodium hydroxide, and your goal is to make 0.125 molar sodium hydroxide solution. Right? We want to figure out what the maximum volume of solution that can be created if we use up the entire 10.199 grams of solid. Right? And the problem's giving us the molar mass of sodium hydroxide, 39.997 grams per mole. All right, so the first step, we're going to use that molar mass to determine how many moles of sodium hydroxide we have to work with. So we're going to take the initial mass, we're going to divide by the molar mass of sodium hydroxide and come up with the number of moles of sodium hydroxide, our total number of moles. Now, we are given this fixed number of moles, and we know that at the end of the day, we want to end up with a 0.215 molar solution. So what we're going to do is take that number of moles, and if we divide by the concentration, this is our desired concentration, then moles sodium hydroxide cancels out. We're left in units of liters, and because our desired concentration here is known to three significant figures, we're going to have three significant figures in our answer, which is 2.04 liters. So in other words, if you want to use up all of your 10.199 grams of sodium hydroxide and make a 0.215 molar solution, the greatest volume you can come up with is 2.04 liters. All right, so to summarize this, what we've seen here is that if you want to prepare a solution, the key part to remember is you add your solid first, dissolve that solid in DI water, and then bring the final volume to that desired value. Okay? And then, of course, we're using our units of molarity, and you have to remember how to do those different unit conversion steps that you saw in the last two examples.